Okay. And I came over here to get the, oh yes, midterm project. And that's why I name it the midterm project rather than test. It's a thing you're doing rather than here I get to punish you. Okay, I'm gonna download this. And then open that. And let's see here. How did it, let's see if I can come over here. Is it gonna let me drop that into anything? Nope. How about we upload? I just recently learned we could do this. So future reference, you can upload different types of files into Fusion and it will open them. So here I have uploaded the PDF to Fusion as well. Yeah, kind of cool. Okie dokie. Sorry, so I'm going to close that one and I'm going to save this as Todd midterm. What's that? Who is that guy? Okay, so once again, we got the 2-inch by 3-inch by 1.13 obnoxiousness. I'm going to be lazy and just go with the 3.5 by 2.5 that I had seen earlier. I don't feel like wasting you guys' time by trying to find the perfect stock. So I'm going to create a sketch, going to grab over here and a 2-point rectangle. And I'm going to go this time with a center rectangle because I feel like it. Setting that for 3 inches. And this one for 2 inches. And that's pretty cool. So now I'm going to, let's see, actually, I think I'm going to make all that construction because I feel like it. All right, so we were offsetting this one here a distance. Oh, the wrong one. I meant this one. Offsetting this one here a distance, and that happens to be ½ inch. Negative 0.5. Okay, and let's see. Next one is 1.48. We have 1.48. And let's see here. Then we've got an inch. We'll come back to that one. And we've got a 0.65. That's a square 1 inch. Okay. So we go bump with a bump and a negative 0.65 there. We have a rectangle or a square coming off of that. Anything else I need? Yes, I've got a 0.39 and a 0.76. So I'm going to come over here. I'm going to say, is that what I want to do? Maybe I'm going to do it differently this time. Maybe I'm going to go line, say out to here. Make sure it's flat. There we go. And then I wanted another one. There we are. And that was 0.39 and 0.76. So, 0.39 and a 2 0.76. Okay, so now I've got my grid work there, so I'm going to finish that sketch. Here's my construction. So now I'm going to create a new sketch on that same plane. And I'm going to go with a 2-point rectangle, snap to that corner, snap to that corner. I'm going to then snap to that intersection. Come down about so. And I want a circle there and a circle there. Notice I'm not worried about sizes yet. I know I want this one to be a square. And I want it to be 1 inch. Okay. Let's see here. What else are we gonna do? Oh, I know. This one, I'm gonna thread this one. So let's go find that information. So that's gonna be a Capdrill chart. And we can go grab one of these and find the quarter 20. There it is. They're saying a number 7, which is up 0.201. Okay. So yeah, 0.201. And then this one is 0.3. And it's a counter bore. Well, not really a counter bore. That's the wrong symbol, but it's a flat bottom hole blind at a 0.55. Okay, but it is a 0.3 diameter. There we are. Finish sketch. Cool. All right, so I think this time I'm going to extrude all the everything straight down, except for that one hole. And I'm going to that down to a negative 0.313. Is that right? 0.313 or 113. There we go. 113. All right, bang. But that turned my sketch off. That's okay. I come over here and turn it back on. Ta-da! I'm gonna turn that one off there. I don't need it. Okay, now so this hole is a 0.55 deep. Okay, so let's do that. So I'm going to extrude, say that one and that one. And they're going to go in a negative 0.55. Zoink. There they are. Fabu. Okay, now for fillets and chamfers and all that other good stuff. So it looks like on this blueprint, there's just one line on these corners. So they want the top chamfered first. So I'll do that. And the note says, corner chamfers are 20 thou, top face chamfers are 50 thou. Okay, cool. Oh, I should probably fillet those corners first so we don't get a weird effect. And those are 0.13. All right. You, and you. 0.13. Cool. Sketch off now. And now that we have that, let's go up here and chamfer. And everything wants a 50 thou chamfer. Okay. From there, I'm going to start a new selection set. I'm going to grab corner, 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 and corner. Set that for 20 thou. Oh, it cheated. Look at that. Not supposed to do that. Well, we can, sometimes the model does not have to actually match the finished part, because we can get this to have a single line here by cutting it that way. We can also, when we run into things like that, we can run it by the engineer for the client and say, hey, I got this one little feature. Is it any kind of a problem or not? And they might say, no, 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 that has to be exactly like the blueprint. Or they might say, I don't care. So, whatever.
That 50 thou, or the 50 thou chamfer off the face, it did the four corners first and then did the face. Like if you undid it, went back a few steps and did the four corners first.
I'm sorry, I'm having trouble understanding what you said. You're a little garbled.
Oh, I was just saying if you did the four corners first and then did the 50 thou on the face,
Let's try it. Let's try it, see if that works. Usually goes the other way about, but I'm delighted if it will not. Yeah, no.
What if instead of selecting the corners, you just select each side?
Could be that. Or we could, we can just select that little face right there and delete it.
Okay.
Hook or by crook?
Yeah, I think mine had a little funky on the one I did.
No worries. I'm not actually fussy about that and truly don't care what you ended up doing. I just wanted to bring up that sometimes issues like these can come up on the job, and there's a whole bunch of different ways of solving it. Sometimes there's a fix like this. Sometimes it's, like I said, contacting your client. Anyhow, here we are. So, I'm going to make a stock model because, as you all know, I like to. So I'm going to go over here to offset plane. Grab that face there, dink. And I'm going to bump that up 50,000. Okay. And then I'm going to create sketch based off of that plane. Dink. There it is. And in order to get a center point, I'm going to hit P for project and grab 2 relevant edges, which will allow me to create a construction line, dead center. So I can now create a box. Oh, I said create a box for my stock. Oh, but it's still in construction. You genius. All right. There we go. That's better. And we're setting this one for, come on. Be nice. We're setting this one for 3.5 inches. And this one for 2.5 inches. And then we're going to extrude a solid, a distance. We're going to make sure it's in a new body though. And that distance is going to be 1.13 plus some amount. So we're going to add in some for safety. So let's add in 50 or 100. 50 is all right, usually. Plus however much we're going to hold in the jaw. So Mighty Bytes are like a 113. So if we give a 0.15, then, oh, I was going the wrong direction, wasn't I? Minus, there we go. Minus, aha. That'll give plenty of extra down there and have nice safety. And then we can use any kind of dovetail that the operator wants to do, or setup person. All right, here we are. Bang. Nice big block. I'm going to go to bodies, going to go to body 2. I'm going to go to opacity control, and I'm going to set that for 30%. There it is. Nice and lovely. It's a little big, that piece of stock. Spending some time to find a more efficient piece of stock might be good, but at the same time, if you're running a dedicated machine to a particular material, that much extra is no big deal at all. Welcome, Madeline. And we're going to go from design, we're going to come down here to manufacture. Okay, so before I jump over to start the tool pathing, what do you guys think on that method for setting up our model? I did it slightly differently than I did Monday. But those are all totally legitimate methods. Is there anything that you want to see again, or anything that was confusing? All right, pressing on.
Will
Go
we generate
ahead.
code?
Sorry, I stepped on your line. What was that?
Will we be able to see how to generate code with what we've
Yes.
done?
Yes, well, let's do that today. All right.
Thank you.
Okay, facing. Right. Let's grab this one here. I was thinking about shifting over to a 1/2 inch end mill to do the facing for this, to show you a little more of the control for the facing. But maybe we'll do that another time. Okay, so select. How are you guys for setting up your tools? Any problems there, or is that going okay? Hasn't gotten there yet. Okay. All right. So there's our face mill. It's not quite right. I mean, that's okay. There's nothing really wrong with that. But the ones that we have a 45-degree off of it. And I like to represent that just in case. So we're going to go back into tool. And then we're going to go back into this one. Give it a right click and go to edit. Then we can go to cutter and make our adjustments. So ours is a 4-flute. And the inserts are made of carbide. We have a 45-degree taper. And the quarter radius is about 30 thou. It's a little more than 30 thou, but that'll do. Okay, now I'm going to go back to general. 2-inch face mill, 4-flute. I put in the 4-flute because we have some 3-flute face mills in the shop, and I want to be clear which one they grab. And flat tip. So I'm going to copy that, and now I'm going to go over to post processor and put that in there. That way my operator will see it. We could go into this other stuff here, but there's no real need. Except. Now, I wanted to point out that when you first select your tool, you're pulling it from the library, and so you can't edit it. Once you have it checked out from the library, then you can go back in and make changes. It's kind of obnoxious, but that's how it is. Okay, our spindle speed is 7 thou, and you guys have all seen now how I got there. And we can go through that again if you guys want at some point. Cutting feed rate, we're going to go with a 150 for roughing. Then we're going to slow it down for our finish. Plunge, we're going to go with half of our feed rate, or 20, whichever is lower, which happens to be 20. Okay, any questions on that? Okay, pressing on. Geometry. As we see here, they have selected, oh, I know what I got wrong. I know what I got wrong. I got too excited. I got way too excited. So I'm going to just click on that OK and come back to that. Because I did not go to setup. So I'm going to go over here. It gave us a default setup of probably something close to what we want. It's guessing, it's hoping. So I'm going to go over there now and edit. Okay, let's select that machine first. And if you get this far, you will have the most recent machines that you have used. If not, nothing will be there. And so you can then go over to Fusion Library, come down here to Haas. I've had some mixed results lately with updating these machines. And I'm trying to understand why it's sometimes great and sometimes not so much. I'll be reporting back as soon as I can wrangle
Should I
it.
make a new model?
Was that?
Should I start over?
You can do whatever makes you happy. I'm less concerned about the model as the tool pathing anyway. I'm inclined towards, actually, now that I think about it, unless you're going to be offended by your model, then I don't care. As long as you can cut what you made, that I care about. Okay, so I'm going to group on over here to Haas AB Trunnion, dink, and select that. We're not going to be using the A or the B, but I want to make sure those get locked down. All right, as you guys know, after I select the machine, I like to go over and pick the stock. You don't have to, you can do your own method. And I'm going to pick from solid, and I'm going to come over here to models and grab body 2. While I'm here, is it going to let me? It's not going to let me. I have to do that and generate. All right, or design. Okay, I want to change those names. Setup. Okay, I like the orientation already, so I don't have to change that. But I do want to change the model to being my part model. And I'm going to turn off body 2 and switch this to model box point, and then box point, and I pick this corner back here because that's what the blueprint said to do. Okay, any questions to this point? Think we got it? Cool. Cool. All right, post processor is where we're going to put in the number that we're going to use. And I'm going to use 50824. It's going to be mid-term top 1. There we are. Okay, now let's go back to the face and fix a couple things. So we still have the tool, all that set up there. Geometry, I'm going to turn my body 2 back on so I can select that. And now I have a closed chain that's going to use for that. Don't make the mistake of selecting your part. Select your stock, please. You'll be glad. Heights, starting at the bottom, it defaulted model top, and that is perfect. That'll do. Top height, it then went to stock top, just fine and dandy. Feed, top height plus, well, that's a bit much. I mean, do what you want, but I think I like 100 thou better. Retract height. Well, 200 thou above stock top is exactly the same, but I prefer to have it feed and change that to a 0.1. And then you can have whatever you want here. Makes sense to you. I like, keep hitting enter. Okay. I like having 2 inches above my my clearance to be 2 inches above the retract height. Do it makes you happy. Okay, passes. Pass extension, I want it to come down a little outside of my stock, but more than 4/10. Half or 1 inch is the radius of our tool. So I'm going to put in, I don't know, this time I think I'm going to do a 1/4 inch. I'm feeling nervous. Multiple depths, yes, please. I could change the step over, but it's very frustrating. We'll do that when we use a 1/2 inch end mill, and you can see some of my frustration with this. I want a finishing step. And I want it to slow down to an 80 for a nice pretty feed. That last step down, I'm gonna set that for 20 thou. And linking. Keep tool down. I want this to be something ridiculous. Extend before retract, so it leaves the stock first. No vertical lead in. Okay, so
So I got a quick question.
yeah,
You never want to use vertical leading?
you can. You can use it if you want to. I, as an operator, hate it with every fraction of my soul.
So with every tool or every instance you've ever seen, vertical lead-in is no good.
I don't like it as an operator. There are times when it's appropriate when you are using a ball end mill, for example, and you're stitching a sloped shape. Sometimes it's nice to have a vertical lead in, just in case you don't have room for a horizontal lead in. I have at times used it, but for the most part, it's going to cause undue anxiety to your setup person, or an operator. How's that?
Okay, thank you.
No problem. Now, we have a little bit of a goalpost here, and I don't love that for this type of toolpath. So I'm going to give that a right click, go to edit, and I'm going to go back to linking. No, passes. There it is. Saw it. Where's keep tool down? Let's try from other side. Nope, that was not it. Where? Let's try both sides. Nope, that's not it. Where's that hiding from me? Both sides. Season step downs, finishing step down. Wow, what's going on? I have clicked. Okay, here's the problem. They're ignoring me. So I have keep tool down, but it's decided to do whatever it feels like anyway. And that's always lovely. He says ironically. Is there another reason that I'm missing? Huh. Huh. Well, fine. It's being rude and ignoring what I'm telling it to do, but I guess it's no real crisis. There it goes. Okay, let's do a periphery. I'm going to go to 2D contour. And I'm going to change that tool. Milling tools, flat and mill. And we're going to go to a 1/2 inch flat. Now, we can set this for a aluminum roughing, and it should give us a better feed and speed, but we'll find out. And I'm going to go back in. Let's see. So it's doing okay, but surface speed is too high. Okay, we're gonna have to make some changes. Okay, so we're gonna go into right click here and edit tool. Eventually. There it goes. Going to cutter. And we need to adjust the number of flutes because what we have are four flute end mills. The material I'm choosing is HSS. My flute is about an 1.33 inches long-ish. And then it gets upset. I say, that's okay. And then you get upset. Where I say, that's okay. There we go. Nice. So I'm going to come back over here to general. And we're going to say, for flute, HSS. And maybe we're going to leave a different note this time. Let's go with, let's try this. Separate some of that data here, huh? And that this is a 1.3 inch crowd or stick out or whatever you want to use. Oh, I didn't want to hit that except cancel. Thank you. I wanted to grab. Oh, did I lose all my changes? Did I lose my changes? I did. That's awesome. Okay, let's do that again. Good times. Crowd. At which point I'm going to copy all of it. Go to cutter. Re-put in the data that I lost. Always favorite. Let's try at the top here since I know what that's going to be. So go 1.5. Is he going to get less grumpy this way? 1.4. And of course, it's better to put in the real data, but this is close enough for our usage. And then I'm going to put in a comment here for the operator. Okay, let's accept that. Yes. Okie dokie. Now I'm going to go back to our canvas, going to files, scrolling down to speeds and feeds. Coming down here to not solid carbide, but HSS for non-ferrous, babu. And they're recommending an SFM between 450 and 650. Okay. I'm gonna come over here and oh, I needed one last select. Here we go. There we are. So for some reason, they've got that surface speed at 1,000. I'm not sure what's going on there, but we're going to go 625, a little bit less than maximum. And our feed per tooth or a 1/2 inch end mill is 6 thou for good solid rough. And feed per tooth is okay. They were pretty close to what I had going on. Okay. Feeling better. I like that. We're gonna change that plunge to a 20. The ramp should have updated as well. Make sure that's correct. All right, feeling good. Contour. I'm going to go with chain. I want to go with closed chain, and I'm going to grab that chain right there. I could grab the one above, but it has a little bit of a Z change on that corner. And sometimes that's fine, and sometimes it causes no end of chaos. So I'm grabbing this one down here. Aha. Make sure the arrow is pointing in the correct direction. We want to go clockwise around it. Grabbing that, okay. Stock contours. You know, let's try it. Let's add it in, see if it does anything good for us this time. Sure, why not? No tabs, dress machining, tool orientation, we're good. Heights. Okay. I'm going to go, well, selected contour, because I grabbed the bottom of the part, would do fine. Or model bottom, either way. I like model bottom because then I can see this blue line and have surprises. There's other very good reasons for picking other stuff. I don't need stock top because I've already faced, so I'm going to go to model top. And then feed height is going to be top height plus a 0.1. And retract is going to be feed height plus a 0.1. And my clearance is going to be my retract height plus 2 inches. Okay. So you guys should be pretty familiar with this at this point. I use pretty much the same values every time. You don't have to do the same thing. We're not going to do anything with machining type. We're now going to groove on over to linking. Oh, wait, nope. I need passes. Sorry. Accidentally skipped passes. So, compensation type. Big deal here. I enthusiastically recommend wear. You will be glad. I'm going to skip making sharp corners for now. Sharp corners can leave burrs on the vertical corners if we're not careful, but sometimes Fusion will round that corner off a little bit if we don't. So we're going to see what it's doing this time. My finish feed rate is going to be much slower than that. We're going to take that value and divide that by 3, and it's going to be pretty close to 40 thou. It's not going to do the math for us this time. That's okay. Thus, we have a calculator over there, so I'm just going to put in a 40 thou. I think it comes out to 38 point something. Finishing overlap. I might have to use it, but I'm going to try not to. Rolling around the corners. Yep, that'll do for now. Roughing passes. Okay, so the roughing passes are going to be the radial step over. And they're defaulting to 1/8 of an inch. Sure, okay. Yeah, I can accept that. How many of those do we want? Well, let's see. We have a 1/4 inch. So we need at least 2 of them. Let's see what that looks like, if that's going to take care of our corners properly or not. Multiple depths. Yes, please. So maximum roughing step down, they went straight for the maximum of the 0.75. We can do that, but we're going to have to take multiple steps anyway. Well, let's leave it at 0.75, see what happens. Sure, why not? Now, we don't need a finishing step down because that's going to be out here on that shoulder, and that's going to get cut away and up to anyhow. Oh, that reminds me of something. Okay, we'll talk about it. We'll come back to it later. Finish only at final depth. Don't forget that little clicky right there. That will shorten your time by quite a bit. And I'm going to go with even step downs so that I don't have to do math. And I like being lazy. Lazy. We're not going to worry about stock to leave, but we are going to turn on smoothing. That will make less code. It'll give more radiuses. I'm not going to bother with feed optimization for now. Linking. Let's keep tool down. And I want something ridiculous under there. For maximum, stay down. Okay. Now, I'm going to leave these alone for now, just so we can get a look at it, but I'm pretty confident I'm going to want to change them. What's that? And then I'm going to kill the horrible, horrible, evil, bad vertical lead-in. Okay, now I'm going to choose a position for coming in and leaving and such. And see if I can get Fusion to play nice. So I'm thinking I'm going to try a lead-in position of this corner right, or this edge right here. Let's see if that does what we want or not. Okay, here we go. Well, the lead in, lead out look to be on a decent position. Let's run it. I definitely want to make some changes in here. But also looks like it's going to take too much on that first cut. Let's go to simulate, not edit. Stop it. There we go. Coming down in really close. Look at that. Look at that. That is no good. It's really close to our stock. That's just not nice. That's not nice to our. Ooh, big heavy cut. Pow. It can theoretically take that, especially if it's in dovetails, but I think it's a little. That's a little aggressive. Nice cuts after that, though. So we can see that it, by clicking on even depths, it took less than a 0.7 on the way down. It divided it in two, essentially. So it did the math instead of me. Ooh. Nice, slow, pretty. Around the corners. Now is good. Okay. So that worked out pretty well. I like that tool path. It's very aggressive. That will not, that tool path would not survive a flat steel jaw. It would fling, guaranteed. So in our setup sheet, we're going to want to mention the need for a strong grip such as dovetails or mighty bites. Okay. So I'm going to go back in there and make a couple changes. Let's see. For one, let's add another pass. For two, I didn't like how close it was coming in there. So let's change from 50 thou. Let's make that 1/8 of an inch, see what that looks like. And same with our lead in. I'm probably going to want a larger value in my lead in radius though. Ooh, ooh, that's nice. Oh, I don't like that position right there. See if we can fix that. But it's gonna knock off those corners first. Quickly. Then it's gonna come in. Hmm. Hmm. Let's see what that looks like. Oh, silly. Simulate. Here we go. Coming in reasonably distant. Cuts that corner. Cuts the corner. Cuts the corner. Cuts the corner and then goes right into a cut. Pretty good. Very aggressive. Corner. 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 Hit. Hmm. Okay. Don't love the lead in, lead out. It's gonna leave a ding right along this face right there. Let's see if we can fix that. Now, if you don't like the up and down, because that's gonna kill some of our time, that slow feeding down. If you want to be rid of that, then we can go into edit and go to geometry and turn off stock contour. Okay, linking. I'm going to kill that preferred lead in and go with a preferred exit and see if that will take. Nope, did not. Try again. Edit. Nope, totally ignoring me. I love it. Okay, how about instead we go with preferred lead in. There we go. There we go. Sometimes you just got to fiddle around with it. We got there. Okay, let's run this one, see what it looks like. And you see that we have much less plunging in terms of time. I did it again. And now simulate. Corner. 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 There we go. Nice. I liked it. And pow, right on the corner. Very good. Okay, so at this point, I'm pretty pleased with that. So I'm going to come over here and turn off my models so I can come in and see what it's predicting. So it's giving me a pretty good prediction of that corner here. It's not perfectly crisp. So if we wanted to, we could make some adjustments, but I'm pleased enough with that, in that it will have less of a burr. Less deburring is good. Okay. Exit simulation. And you can make your own decisions if you want that to just knock off those corners first with rapids or knock off the corner with feeds. Both are legitimate. Okay. Turning my models back on. Any questions on the toolpath there? That's the big deal. That one right there is your moneymaker. That is the bulk of your job, is getting Contour to work. So, questions, gimme. Nothing? Nothing, tra-la-la? Okay, okay. I have faith in you. All righty. So next, we're going to be doing some drilling and pocketing and whatnot. And then after that, we're going to be doing some chamfering. So I'm going to save what I've done because I have not previously, and that is not wise. Okay. I'm going to go back to design at this point. And I'm going to create a sketch on, let's turn that second body off, on the face of my part, pardon me. And I'm going to be putting in some drill holes. I need a line that goes from the center of that line to the center of that line. I'm going to I might do something silly. I'm going to do something silly. Why not? So let's see, how shall I do that? I've never done this. We're going to find out how, if it works or not. I'm going to put a circle here, and I'm going to just make something random there. And one there. Okay, and let's say we go to solid, extrude. I'm going to extrude those down just a little ways. Okay. And then I'm going to chamfer that edge to 50 thou. Yeah. Let's see if this works out. It's kind of silly, but I like it at the moment. So now we're going to go back over here to manufacture. And I'm going to then go to drill. I'm going to select a 1/2 inch. Go hole making tools. Inch. Spot drill. Grabbing a 1/2 inch. Okay. And I'm not going to deal with speeds and feeds yet. I'm going to come back to that. Geometry. I'm going to go, I want that one, I want that one, and I want that one. And I'm going to top height. We're going to set that for the model top. And the feed height is going to be top height plus 0.1. Retract is going to be feed height plus 0.1. And our clearance is going to be retract plus 2 inches. Okay. I love it. Okay, drilling, wrap it out. So now, I don't have to create a separate tool path for the spot drill here. And I can then just turn that third body off and I still have the tool path. Ooh-ha. Huh? Do you like that? I like that. Ooh-ha. Okay. So next, I'm going to drill. So I'm going to grab here, grab a drill, and I'm going to select hole making tools. And it's going to be a drill. And my diameter is going to be equal to a 0.201, which does not match anything. Interesting. Okay, let's go with something that is less than a 1/4 inch. Oh, because I grabbed metric, that's why. Silly. Okay, and here we have the 0.201, which is the number 7. Grabbing that one. And once again, I'm going to come back to the speeds and feeds because I feel like it. Geometry. I am going to go with selected point, the middle of that hole. My heights. I'm going to say select. Oh, I forgot. That's a through hole. So I'm actually going to say from stock bottom, I'm going to say drill tip through bottom. And I'm going to go at least 50 thou past. Okay, top height is going to be model top. My feed height is going to be top height plus 0.1. Retract is feed height plus 0.1. And my retract is going to be 2 inches. Okay, et viola, but don't stop there. Students do this all the time because the cycle defaulted to rapid out, and you can do that, but you're probably going to break a tool. It might work. Probably won't. So instead, I'm going to pick some kind of a chip break, be it chip breaking, partial retract, or deep drilling full retract. I tend to like deep drilling full retract unless I'm trying to eke out every second possible. And I'm not. Okay. I don't think we need to adjust any of those. Those look just fine. There it goes. So if we run this, what we have so far. Facing came down well off the stock and travels well past the stock. There we go. I like it. I don't like the amount of overlap there. We're going to get a lot more burnishing that we want, but Fusion is a magnificent pain in the arse to control it that way. So we're just not going to deal with it for now. Later on, we're going to look at Mastercam and show you what's supposed to happen. Also, later on, I would like to go over the lathe this term. So we'll hang on to that. Round and round. That looks nice. Okay. Spot. Notice that we pre-chamfered with that method. Very nice. Toot, 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 toot. Speed that up a little bit. Losing patience. What's happening? Why is it starting over? Oh, right, because I didn't do anything else. Okay, so that looked pretty good. And our statistics are about 2.5 minutes. That's okay. That ain't bad. All right, exit sim. There we are. And then more drilling. Okay, so. I can hit that drill here. And tool. And hole making tools, Imperial. Drill. And this one, my diameter, is going to be something that is greater than 0.25. Okay. So the hole is 0.3. So if I put 10 thou on a side, that's going to shrink it by 20 thou. So we want something in the realm of a 0.28, which is a K. And I'm always humored to drop a K hole. So let's do that. And again, speeds and feeds, we'll come back. I recommend selected points, but do what you like. And I'm actually going to turn this third body back on so I can grab the middle of that hole as well. I love it. How silly is that? But it made my life easy. I mean, come on. Okay. Okay, so bottom height is going to be selection, and I'm going to pick an endpoint at the bottom there. And I'm going to bump that up into the air by a positive 10 or 20 thou. Go with 20 today. That way we can clean up the bottom and not risk a little ding down there. Top height, I don't recommend whole top because depending on what you selected may or may not do things the way you want. I'm going to go with model top. And my feed height is going to be top height plus. What do you think? What's it going to be? 100 thou. Yeah, yeah. My feed height is going, or my retract height is going to be my feed height plus 0.1. And my clearance is my retract plus inches. Okay. I like it. Make sure it is on deep drilling full retract. Okay. And there we are. It's got a little wall you can see here. We're going to end up cleaning up. All right. So let's come in here and pocket, shall we? Let's. 2D pocket. And let's select a 1/4 inch end mill. Flat end mill. And I'm picking 1/4 inch because those inside corners of that pocket are a 0.13, a little bit larger than the radius of a 1/4 inch drill or end mill, that is. Cool. Okay. Here we are. This time I'm going to use carbide. So I'm going to come up here and carbide, non-ferrous, 1/4 inch end mill, and we're going to heavy periphery. And they're saying 800 to max. What does that mean? Max. Max of what? Yeah, it's going to affect spindle speed. But what's being maximumed? What's being maxed out here? The speed. So as fast as your machine can go, that aluminum likes it. So wind it up. Now, we don't want to hit actual maximum speed, but we want to get it close. We don't want to, but he won't. We're not going to melt it. It's aluminum. As long as we keep a good feed rate in relation to that, it's just going to fly. So that's what we'll do. And we're going to do heavy periphery. So that's going to be 2 and 9. So 2 thou and 9/10. Okay, well, but it says max. That makes it real easy. So I can come over here and, well, let's look at a little bit of math here. So if we put it in the minimum surface speed of 800, we have a spindle speed of 12,000 recommendation. Well, we do have a machine that can do that. And if we were to do that, we would need to make a note in the setup sheet that it must run on the SS. But I don't want that. I want that to run on any of them. So I'm going to, well, I'm just going to leave that there for now. And we're going to look at something. I'm going to set my feed per tooth to the 2 and 9. Is that what it was? Yep, 2 and, oh, yep, 2 and 9. There we are. Okay. So that's going to give us a feed rate of 106. Well, as I said, we can't run that fast. So I'm going to come up here. I'm going to set my spindle speed for 7 thou. So the question was, if the machine cannot run that fast, will it error out? Some brands, yes, some brands, no. And that's the problem. It will still keep the same feed rate. So now, if we have it set for 12,000, but it can only spin up to 7,000, it will still try to feed at 106 instead of, as we see here, 60. That's a bad thing. Yeah. But because we set our feed per tooth, it keeps the ratios together So now we have a cutting feed rate of 60 and the tool will survive that. Yeah. Yep. Feeling good about that one. Okay, plunge. They've got that down to 20 already for us, so we'll take it. The pocket. You can choose what you like here to make it work. I tend to like chain, personally. It's what I trained on most. Okay, there we are. We'll make sure the arrow is on the correct side of the line. I think everything is good there. Our heights. We could use selected contour. I'm going to go with selection, though. It's up to you. Top height is going to be model top. Our feed height is going to be top height plus 100 thou. Retract height is going to be our feed height plus 100 thou. And our clearance is going to be 2 inches. Okay, passes. All right. Well, I want finishing passes and I want multiple depths. Let's turn those on now. I'm gonna move this up so we can see things. And move zoom out of my way. No, I don't want apps. Go away. There we are. Okay. So sideways compensation is to the left, cutter comp, yeah. I don't want to go both ways on this one, but we could. I'm going to skip that. Maximum step over of 150. That's pretty heavy. Let's get a look at it, see what happens. Now, we've done this before, looking at the difference between morph spiral or not. I tend to like morph spiral. I tend to leave it on. Flat end mill won't leave cusps anyway, so we're going to skip that. Okay. Well, that's a little confusing. I've got a maximum roughing step here and a maximum step over there. Those seem to be contrasting. Let's see what that means. I don't know. I don't know why they have the same thing in two places. So let's make that maximum rough step 100 thou. Finishing step down, I do want one, yes, please. And I want that to be, I tend to default to about 10 thou. Does makes you happy. Finish only at final depth, yes, please. Okay. I'm gonna leave rough final on. Use even step downs, I like that, yeah. Oh, I see what I was confused. Silly me. I apologize. We're depth cutting rather than radial cutting. Sorry. That's silly of me. So maximum axial step down of 100 thou. Well, let's go look at our chart. Now, it's going to be different numbers if we're looking at carbide versus HSS. So I come over here and look at the carbide. And they say for heavy peripheral, axial depth of up to our diameter. So I could do a 1/4 inch down in Z. And they don't want to do a radial step larger than our radius. So we might have to make some adjustments there. Okay, so maximum step over is over our radius. So let's shrink that down to just the 100 thou. And our step downs for roughing, let's leave that at 0.1. I think it's a little shy. Let's come back and look at it later. I just want to see what it does. Finishing passes. Let's change that to where? Absolutely. our one finishing pass, step over, that's what I was looking for. Let's go with like a 10 or 20 thou. I'm thinking 10. It's up to you. Leads on all finishing passes, yes. Finishing feed rate. Well, that's the same feed as we had for our roughing, isn't it? So we're going to do that divided by 3 thing. That means we're going to have a feed rate of 10. Something seems wrong. That seems very slow. We're going to come back and look at something. I feel like I forgot something. I'm not sure what. Stock to leave, no. Finishing overlap, probably, because we have no corners really. So let's give that 1/8 of an inch. Smoothing. And then feed optimization. Let's slow it down a little bit when it hits those corners. I'm going to hang on to these numbers for now because something's tickling my brain that I forgot something. We're going to come back. Okay. So under linking, safe distance, yeah, maximum stay down should be something ridiculous. Vertical dies. I won't mark you down for leaving that in, by the by. This is just my preference. Okay, we are going to plunge down in our pre-drill hole. And let's see, what's this? Ramp radial clearance. No. And our pre-drill position is going to be the middle of that circle. Okay, turn that back off. Let's see how we did. Coming in, it looks nice. Nice spiral, slows down on the corners. That's looking okay. I'd like something larger, bring it back towards the middle a little bit for the lead in, lead out. But otherwise, looking decent. I don't love that it's traveling so much on that corner. That's a lot of contact there. Such is life. Okay, I think it'll be fine. So I'm going to go back to linking. And as I had mentioned, this is not enough. I'm going to raise this to a little bit more than my radius. So it's a 0.3 or 0.13. My linear lead-in distance is going to be the same thing. And I'm going to shrink that to like bring the tips together closer to a 120. See what that does for us. The tool, that's what was bothering me. I didn't adjust the tool. There it is. Come on. There we go. Okay, so a 3 flute's just fine for this, especially since we're going to be down in a pocket. I'm actually going to recommend that 3 flute. Yeah, that's a good idea. And we're going to go carbide. Okay, flute depth is 3/4 inch. That's going to be just plenty. Okay, I'm liking that. So we're going to go over here to general. And put in notes of 3 flute carbide. We're going to say greater than 0.6 proud or Whatever you want, it's gonna make sense. Oh, I'd need to get the inches on that. Okay. Okay, so I had set up the feed optimization, and there we go. It's gonna slow down a little bit on those corners. Cool. It's not gonna slow down much. Okay, so now you can see my lead in, lead out is going to travel a bit further, but I'm more comfortable with that. The only downside is it's going to get a little close to this wall on the way out, but I think it will be fine. Okay. Let's see what we did on that. There. There. Way too much overlap, but fine. Knocking the corners off. Bump, bump, bump. Drilling down in. Drilling down in. Drilling down in. Plunging, cutting. It's weird how it ran the other direction there for a moment. Okay. Did it again. All right. Here we go. Love it. Okay. Next is we're going to see if we can do the same tool on that bore or not. So it'd be nice if we could. So geometry. I'm going to try selecting the whole wall. It looks like it's just going to helix all the way down. That'll do fine, except I don't want some of that. I'm going to make some changes. Heights. Well, got the whole bottom. That's fine. Top height is I'm going to change that to whole bottom. And I'm going to bump that up by, oh, I don't know, 200,000. I don't need that much. Let's call it 1/8 of an inch. There we go. Honestly, probably more than we need. Retract is going to be based off of top height plus, well, we don't have a feed height on this. So I'm going to leave that top height plus 200,000. And set that for a 2 inches. Passes. Yes, I want a finishing pass, please. Step over. I only want 10,000. Compensation is to wear. Don't forget that, please. Very important. Now, we're going to keep tool down and we're going to lead to center. Very important. Lead to center is what's going to protect our walls here. Okay. I like how that looks. That little diamond there. Okay. Let's look at that one, see what it does. Now we're going to want to make some changes. So that's going to scare the pschnork out of our operator. If it's plunging at rapid down the middle of the hole. No, 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 no. That is not a kindness. So with other products other than Fusion, you can control that better. But with Fusion, you can't, or at least I haven't found it. So I'm going to make some changes. I'm going to then make a note in the comments saying, so we're going to change the, I think that's the wrong spelling, isn't it? There we go. Change the bore plunge to a feed after we post the code. And make sure you hit post to save it. That way you have a reminder should you have to repost your code that you have to change it in the NC code later. Otherwise, it's going to scare someone to death. All right. Feeling good, feeling good. And now we have two more features to cut of chamfers. All right. And there's a bunch of different ways of doing it. We go up here to 2D. And there is a 2D chamfer. And you can do the same thing with 2D contour. I tend to prefer doing it through 2D contour rather than chamfer. I think I get better results with 2D contour. Do you have to? No. Do what works. I'm going to grab that here now. Okay, so I'm going to go to Tool. I'm going to select. And for your chamfer, we're going to go grab milling. You can use a spot drill for this, or you can use a chamfer mill, whichever brings you joy. I'm going to pick a chamfer mill for this because we have some. It's much easier for finding feeds and speeds for that as well. I'm going to, well, we have a 1/2 inch engraving at 45 degrees. And then we've got a 0.425, I don't know where that's from, chamfer tool at 45 degrees. So there's not really a big difference. I'm going to grab the chamfer because I feel like it. Select, but ours is not shaped like that. So I'm going to go back in and give it a right click, edit, and under cutter, let's see, the tip diameter on ours is significantly smaller. It is, I'd have to go measure it, but I think it's like a 10 thou. But if I just put a 1 on there, then at least it's not going to cut too deep. If anything, it's going to cut too shy, and the operator will have to make an adjustment. And that's fine. The diameter is not 0.425 there. I believe it's a, let's just go with the 0.5, round that out. And the shaft diameter is the same, 0.5. There we go. Number of flutes. I believe mine is a 4 flute. And it is certainly carbide. Okay. That looks a lot more likely. Make some adjustments here. 1/2 inch 45-degree chamfer mill and 4 flute and carbide. Okay. Let's grab that. Accept that. Select. Come back to the speeds and feeds. Geometry. Okay. Again, I tend to prefer chain. You can do what you want. Now, we're probably going to have to do something clever here because of this chamfer. So in order to get that, just that one corner line instead of 2, we're probably going to have to play with things. Well, for now, I'm going to be ignorant and just try this and hope for the best. And, oh, well, kind of the problem here, right? No good. I can't get all the way around here very well. It's kind of fighting me, huh? Well, I can still grab the bottom one, which is basically the same thing, right? All right. Click on that OK. We're going to ignore the rest of that. Okay, now, this is important. Your bottom height is actually your model top. Your top height is also the model top. Feet height going to be top height plus 100 thou. Retract is going to be feet height plus 100 thou. And your clearance, 2 inches. Okay, now, compensation type, let's give it some wear. With the 50 thou, it's probably a good idea to do a depth cut, depending on the type of chamfer mill, but the one that we chose can handle it. I didn't adjust feed rate. I should come back to that one. I'm not going to roughing pass this time. I don't feel like it. Okay, now in chamfer, I'm going to do a tip offset because the tip is most delicate. It's going to be least sharp. We just generally want to avoid it. So I'm going to offset that by at least 50 thou. I'm probably going to offset that by more. I'm going to offset it by 100 thou in this one. Then my chamfer width is going to be a 50 thou. And let's see if it's going to behave correctly. Sometimes it gets a little grumpy with me. All right, keep tool down. And something ridiculous. Let's see. I like more here. I like that to die. Okay, and okay, so our let's try. We like the lead in before, so let's try that there. All right, let's see what happens. Zoink. Very nice. Right there on that corner. Let's see what it does in reality, though. We're going to go to setups and we're going to go to simulate. And we're going to turn our models off. I'm just going to speed through it. Zoink. There's that little triangle that I didn't want. Yeah. Yeah. Okay. Things are looking pretty good, though. Well, let's jump through. Yeah, okay. Let's turn our models back on. How are we going to cure this? Anybody have an idea? I have an idea. What do you guys think? How are we going to cure that little triangle face that we had right here in the actual cut? Anybody have a thought? Well, I built this off of a rectangle. So what if instead on that contour, we change that so that our geometry no, not that. Our geometry, why are you only selecting that stick? Come on, play nice. Why are you being weird? There you go. All right, let's try that. There it is. See? So my point is, there's different ways of dealing with this. Oh, look at that. I don't love. I don't know. I don't know. I might need to adjust this chamfer there. Okay, but I'm not going to bother with it right now. We're going to exit simulation. Duke. Okay, so everything worked pretty well for that chamfer. So what if I were to duplicate it, keep everything the same, but change the chain to being this chain right here. Once again, you want to select the lower of them. There it goes right there. I don't really like this. It's getting awfully close to that edge there. Let's make some adjustments. Okay. So I'm going to come back here to passes. See if I can find finishing overlap. There it is. 125. Let's see what that does. One change at a time. Okay, that's good, but I still don't like where it's coming in there. So let's turn that off. That's better. There we go. All right, let's make sure we got what we wanted on that. Put in setups, simulate, turn the sketches off. Okay. Now, sometimes our inside corners can end up incorrect on a chamfer. Such as if we offset them too much. So if I had, for example, did a 250 thou tip offset, then we're going to get a weird chamfer there. Oop, I just completely ignored us. Okay. Well, I was trying to show you, it has problems on these inside corners. It ends up digging in way too deep, but it looks like Fusion helps prevent that. Okay, there we are. Oh, I haven't tapped. I was going to tap. So I'm going to go over here to drilling. And I'm going to grab the tool. And I'm going to make with the hole making tools, I believe, inch. There we are. And we're going to have a right hand tap. And I want a 1/4-20. 1/4-20. All right. And I'm going to go with center of that hole. My heights is, well, let's go look at that tool. Okay. So this particular cutter looks like it is a plug tap, which means it doesn't have much taper here. So let's see what we can adjust. Well, it's a little short, isn't it? For one. Oh, no. Oh, no, we don't want that. Length below shoulder. Here we go. 2.5 will do. I'm concerned about the diameter though. No, I'm not. I forgot. This is the tap. We're good. Okay. I'm surprised it's not giving us an angle to set on this. So we're going to make a note that's a plug tap. I say that because plug taps have less of a shorter taper. And if they set up for a taper tap, they're probably not going to tap it down far enough. Okay, so then our heights, I'm going to turn on my stock. I want the bottom height to go down to the stock bottom. And we're going to stick down through it a little bit. And let's go like, if we go another 1/8 of an inch down, that should be far enough that we get a nice parallel threads there. We're going to say model top. Feed height is going to be top height plus 0.1. Our retract is going to be feed height plus 0.1. And our clearance is 2 inches. Okay. Now, tapping. Yes. Dwell period, no. But if you're going to tap for more than 3 times your diameter, I recommend tapping with chip breaking. So it's going to protect the tool that way. It won't be as fast. It'll be more like when you hand tap. Okay, that should do. Let's talk about speed and feed on that though. Your feed rate in relation to your spindle is terribly, terribly important for a tap. So if I go look for a calculator, and if I say 1 divided by the threads per inch, this one being 20, we get a 0.05. And that's how far it needs to travel in Z per rotation. So if we had a spindle speed of 100, that's in feet per minute. That's not what I want. Why is it in feet per minute? I don't like that. Well, that's madness. Okay. I don't like that even a little. I'm gonna have to dig in this to find out how to change that to inches per minute. Okay, just type it in. Aha. Inches per minute. There we go. So if we have a spindle of 100 RPM, we would take that value, multiply that times 100, and we have a feed rate of 5 inches per minute. Oh, doesn't like per minute per minute. There we go. This is doing weird shit. I don't like it. I don't like that at all. Okay, let's change that back to 500, where we started, in feet per minute. Okay, I'm gonna have to do some research on how to make this not be insane. Well, okay. Let's look at how they calculated this one. So if we got 1 divided by 20, and we have an RPM of 500. Oh, look at that, sorry. Divided by 20 times 500. And then they've converted that. What are they doing? Feet per minute. All right. Anyway, let's skip it. I'm going to come back to it and try to figure out why they did that and how to change it. Oh, okay. So we'll check that in the code. And you can see that it is cutting into our model there a little bit, as it should. All right. Op 2. You ready for that? I'm going to go up here and start a new setup. And everything is defaulted to the previous. That's great. but I'm going to select ZX for my orientation. I want Z to face the opposite direction. X looks just fine. My origin is going to be model box point. My model is going to be body 1, box point to this back left corner. Click on the OK. All right, here we are. I'm going to grab face. I'm going to duplicate it. I'm going to grab this second face. I'm going to drag it down to setup 2. Drop it on setup 2. Open it up, and there it is. I'm going to right click, edit. I'm going to come actually to tool orientation and use the orientation that it's showing there. If I wanted something different, I'd say Z-axis, direction I wanted, so forth. There we go. But too many cuts. I don't like that. Edit. Let's go to our depth cuts, and I want at least 100 thou. Or, I mean, at most 100 thou. All right, there we go. So now it's going to take 2 roughing passes and then a nice, pretty finish. However, we have a little problem. We have a little problem with that. That is to say, we're only going to be holding onto the sides with a steel jaws. I think we're going to be okay. I don't think it's going to slide, but we'll definitely want to come down and watch the setup person run this to see if it's going to survive or not. We can do something else that's kind of cool here. We go into setup, go into edit, go to stock, and we can go from preceding setup, continue rest machining. Now the stock looks like the up 1 setup or toolpath. Okay, now let's run this and get a look at what it does. It's going to do a thing that I don't actually like. Let's go. Turn off my models. Here we go. Oh, I have a chat. Yes. Hey, Todd. When was that? 6:32. Okay. Just got it. What's up, Kenneth? Or David, or whatever you prefer. I haven't looked at that yet. Hang on, dude. Okay, here we go. Coming in, zoom across, and zoom across, and zoom across. Oh, let's look at that. Let's look at that. See that little foil there? It shouldn't be a problem. However, when it comes through on that finishing pass, there is a chance that it can bend and come up and damage the cutter. Looks like it's leaving a little extra foil there still. We'll deal with that. This foil can actually damage the cutter. It doesn't usually, but it's possible. So we're going to do a thing to protect and prevent for that. What I'm going to do is make a change back in op 1. Turn our models back on. I'm going to go to that 2D contour. I'm going to edit that. And I'm going to have it come down negative 50 thou from the bottom. So it's going to come down a little deeper. All right. Now we want to make sure that we have enough stock there still to hold for that dovetail. It might be I have to adjust my stock now because of that. Okay, so now when we come in with that face and run it, we don't have to worry about that foil. It's gone. Okay. There we are. One done. Midterm. Okay, I'm saving that. Boink. So you guys can get a look at it later if you want. Oh, I didn't set my speeds and feeds for my drilling and for something else. I can't remember what. Oh, chamfer. Okay. So the reason I didn't set my speeds and feeds is I forgot. Okay, let's look at this one here. I'm going to grab that one first. I'm going to come over here and what was my, that's a 0.281. It's K. Okay, so I'm going to search for drill feeds and speeds. Norseman is pretty fantastic for this. I'm also going to open up custompartnet.com. Because, and as you guys know, I do love me some custompartnet.com. If I go to the calculator on Norseman or Viking, it will look familiar. It is custompartnet.com's widget. Identical. Because they said, hey, if you want to, you can. That's pretty cool. All right. So we know our diameter is a 0.20. No. Yeah. No. I forgot. 0.281. There it is. 0.281. Our SFM aluminum and its alloys, they're going to recommend between 200 and 300. So I'm going to pick like a 275. And the IPR, so we are a little bit more than a 1/4 inch. So they're saying 4 thou to 10 thou. I'm going to pick like a 6. All right, so they're suggesting 3,700 with a feed rate of 22.5. Okay. So spindle speed, we're going to turn that down. 3,700 and a feed rate of 22.5. Okay. So they had something much more aggressive. I'm more comfortable here. Okay. I'm actually going to go then back to the spot drill and give it those same numbers. $3,700 and 22.5. Because if I left it to its own devices, they would use a spindle speed based on the diameter of the tool, which is 1/2 inch, but we're not going to use that 1/2 inch diameter. And the chamfer is only slightly larger than the hole that we're doing. So using that feed and speed is going to be decent. Is it perfect? No. We could calculate that if we wanted to, but generally this will do. All right, and then over here to this one here. Everything is the same except our diameter is a 0.201. So if I come back here, 0.201, drop this down maybe a little bit. So we've got a 5 thou and a 21. So there's that 5 thou and the feed rate of 21. Bang. Efficient. No? Okay. And then chamfer. Oh, right. Chamfer feeds and speeds. Find the one that you like. I happen to like the one from Harvey Tool. Speeds and feeds. And I have a 4-flute. And they're going to recommend for 6061 right here, that we have an SFM of 1,000. So I'm going to go back to here and say, let's see, custombartnet.com. I'm going to change that to milling, speed and feed. Number of tooth is a 4. And my SFM, they said 1,000. Oh boy. My feed per tooth and diameter, we got to calculate that. So my effective cutter diameter, well, I offset that by 100 thou from the tip. And we have a 50 thou chamfer, so that's 150 in axial depth. So we're going to double that to a 300 thou. The bottom diameter being a 200 thou, so 200 plus 300, 500 divided by 2 is a 0.25. So here we have that, and they're suggesting for a full chamfer greater than 25 degree is a 2 and 5. Okay, I can do that. So we come back to this one, give it a 0.0025, and we said our effective cutting diameter was a 1/4 inch. So they're suggesting a spindle speed of 15,000 and an RPM or a feed rate of 150. That's fiery. But that's great. That's fine. So now that we've found the ideal ratio, we can just step the ratio down and say, okay, so now instead of that, we're going to set our spindle speed for 7,000. And they're going to suggest a feed rate of 70. Okay. So I'm going to come back here, find that. $7,000 and a feed rate of 70, which seems a little fast to me. But we'll try it. Same thing for this one. There it is, plunge for 20. Okay, now I'm sure there are little things that I've gotten wrong, that I have forgotten, things I've failed to leave notes for, this, that, and the other. But I don't want to take too much of your time. But at this point is when I would go through and double check everything. More importantly, I would take a break I would go somewhere else. I would get a snack. I would look at the trees, play with the dog, kick the children, something. I would not kick the children. I would not kick the children. Well, of course I would not kick the children because my children are bigger than me now and they would kick back harder. I kid. Okay, so whatever you got to do though, to step away and then come back to it, you'll find more errors. What's that? This is due at midnight tonight, but it doesn't have to be perfect. I just want to see what you've gotten to. Okay. Just turn. Yeah, it's fine. It's fine. And if you just turn in a box, that's fine. That shows me your understanding in the time frame. It's okay. Totally okay. Okay. Next. Oh, right. So we're going to talk about you don't need to turn in an actual G code, but let's look at what that would be like, that process. So I'm going to go to setup 1 here, and let's shrink this so we can see everything. Okay, I'm going to go to setup 1. Make sure that the radio button is selected versus setup 2. Setup 1. Okay. So I can go up here to NC program, select that one. We need to make sure that it says pre-NGC HOS. Pull that down, find it if you have to. All this is fine. So we're going to go over here to, oh, I know I was going to change. I want to take this comment and put that in the file name. Otherwise, it's going to make no sense when I'm looking for it. I want chip transport turned on. Option stop turned on. So every time we go to a new toolpath, tool change, anything, we get an option stop. We want safe start on all operations so that it has all the safety code it needs at the start of each toolpath. We want G0, please. If you do not have G0 turned on, it will do this ridiculous thing where instead of using G0, it keeps it in G01 and then feeds at 300 or more. And if you think everything is cool and groovy and you have turned your rapid down to 25% or 5% or whatever, and you think everything is going to be running slowly and suddenly it jumps to 300 feed rate and is not slowed down by your rapid control, it is exciting and potentially disastrous. Please turn on G0. I hate that they have the other option. What's that? Yeah, right. Turn on radius arcs. That will, no, not radius arcs. We don't want that one. Sorry. That one, we'll switch it from IJK to R code. At first I thought it was a different thing and I've gotten that stuck in my head. Such is life. Okay. Let's look at safer tracks. Force XY home position on indexing, sure, if you like. Home position center, sure, yeah. Safer tracks. Do you want G53 or G28? There are arguments for both. We can talk about those later. I'm gonna leave G53 for now. I'm converting over. I used to only do G28. But I see the point of G53. We're not doing multi-axis. Format. I recommend having all 3 of these turned on, but you don't have to. but I do recommend it. But I do suggest you turn on show notes so that the notes that you have put in there go into the code. Probing and inspection, meh. Built in, meh. Okay, now before we go to posting that, go to operations. Make sure that the toolpaths you want are turned on and not the toolpaths you don't want turned on. Do not select reorder to minimize tool changes unless that is for the best. It can cause incredible crashes if you had to swap back and forth between tools. So keep that in mind. All right, let's post that. Bonk. You may end up having to install a viewing software. That's fine. Okay, here we are. And we can see at the very start, we have the O code. We've got some other schneid we're going to get rid of, like, I don't need this. I don't need that warning. That's how it's supposed to go. I don't need those here. It's up to you if you want it, that or not. Now, this isn't bad to have here as a warning, right? This seems redundant. Okay, ooh. Tool 1, diameter, 2-inch. CR, not sure what that is. Oh, corner radius. Yep. Taper 45. Okay. All right. This is good. It's missing some of our notes here. However, so the notes that we had chosen before, that's showing up here. If you want to replace some or all, feel free. You can leave it there. Just do what makes sense for you and for your operators. So here is where the M11, M13 is where it's locking the A and the B axes. So it does not rotate from pressure. All right, so I had a note where I needed to change the bore. So I'm going to groove on down. Well, I'm having trouble finding it, aren't I? That's okay. I can do a thing with a Control F, find, and let's try, is there a bore? There it is, look at that, right? When we have 50,000 lines of code, it makes life better. Okay, so I was going to have it, no worries, you're good. So it's plunging in a negative 0.345. I don't love that. So let's change this to being a plunge to a 0.1. And then it's going to feed down to a Z 0.425. And that's just fine. Okay, everything else looks good. And then I would save. Control F. In almost any document that has actual letters on it, PDF, Word, whatever, Control F will open up Find. Very, very useful. Okay, so what do we think? Overwhelmed. Yes. Yes. That's okay. I want you to show me what you can do. And by the end, and this is going to be your comparative. Because by the end of the term, you'll be able to do this. So, but that's going to take practice. Ooh, I have something in chat. Looks good from Kenneth. All right, sir. Give it a go, guys. Don't stress about it. Now, how to turn that in? Again, you don't need to send me the code. That's fine. We just wanted to look at it and see it. I want you to turn in on Canvas. Let's go look at Canvas. Let's go to where's modules? Why am I not seeing modules? There it is. Okay. Midterm. I want you to turn in, please. In Canvas itself, I want you to turn in your setup sheet. And I want you to leave either in setup sheet or in comments or somewhere the size of your, where you found your stock. And you can either export your Fusion file and then load it in here, or give me access to see it on Fusion. Tell me where you saved it. Let me know where to go look. Okay. I think for the most part, it'll be easier to just export the file and then load it into Canvas, but it's up to you. Just let me know what you chose. Okay. So it is 7 o'clock. And why don't you guys get started if you haven't already, or work on it some more. And I can answer questions and make suggestions. Okay? Cool. All right, so I'm going to stop that share, Mr. Kenneth, and stop the meeting so that you can finish that recording. And then I'm going to start a new one.